let's get into this. Decent soldering iron. You can get away with a cheap one, it's not really necessary. Got a decent bit on it. I tend to run mine up around 325. That's just me. Decent quality bit of solder. Hopefully when you buy your iron, it'll come with a bit of solder. A solder sucker. A lot of people use electric, you know, highly fancy things. I don't do enough soldering it just justify having one, or I don't. It doesn't bother me not to have one. I use these. They're as cheap as chips. Cost about £2 each. You'll get for a few of them in a year, but it doesn't matter. They're that cheap. What does it matter? Okay, on this board here, we've got a couple of things we're going to do. We've got the volume slider here, which if I'm in the board, I've got it out, I'm doing some soldering, I'm going to change it anyway. It's a £3 part, and it costs nothing. For all you foreign viewers, when I talk about £3, that's £3 sterling. So you'll have to do your calculation. I get these off a guy in Spain. He advertises them on eBay. I think it's DIY synth parts or something like that. I can't remember exactly. Switches, tactile switches. I get mine from a company called Farnell's in the UK. I think they're a worldwide thing. I think they do the Elements for You thing as well, don't they? They're basically one of the large electronic wholesalers. Mail order type things like an RS, like radio spares. They're just a competitor to them. The switches I use are the Omron ones, and the part number or the manual number is 3BF1020. Yeah, so there it is there, if you can see it. I don't know if it will focus, hopefully it has. Okay, I'll put a little note in the description, and hopefully that will get you going. So today, I can see a lot of the switches have been replaced before, but there are a few on here that I've tried and are a bit dodgy. So we're going to change this one here, which I believe is the start-stop, the sound. I'm going to change all the function buttons, the user button and the exit button, and I'm also going to change the exit button. Just a matter of course, because the enter button, because that gets used a lot. And I'm in here, I might as well do them. So that's 10 switches in total I'm going to change here. So what we're going to do is, first of all, I'm going to get the display off the board, because I don't want to risk accidentally melting anything. It's a simple process, and we'll get it out of the way, and then we can do the backlight at the same time. So to get the display off, yeah, don't undo these screws here, you don't need to. On the back here there are 4 screws. Yeah, just undo them. Makes life a lot easier if it's off the switchboard. Obviously be careful not to put too much pressure on the switchboard. It's a fairly fragile thing, look. It's fairly flexible, and depending on its age and condition, you don't want to abuse it too much. And then very gently, make sure the cables come through. Just feed them through like this, and you are then left with your display as a separate issue, which you can put to one side for a moment, and your switchboard is a separate issue. Okay, so I know which switches I want to change, but looking from the back side can be a little confusing. So what I normally do is I take a Sharpie and I just figure out which ones are which, and I mark them along the back. It's quite simple, so just put a dot. That one, 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 that one. Okay, so that one is this one, that one is that one. So, what I need to do now is I need to desolder these, and the best way to do that is you take your solder sucker and your soldering iron. If you've got an old circuit board kicking around somewhere, if you want to practice before you attack your switchboard, just find a piece of old electronics somewhere, something that doesn't matter, something that you can doesn't matter if you break it, you know, just find something in a bin somewhere and just try and desolder some stuff on a board that really doesn't matter. Practice makes perfect is the way I look at it. So anyhow, there are 4 prongs on these switches, like so. I don't know if you can see those there. Yeah. They tend to lock themselves together. I'll just pick up another one. Like that. So all 4 of those prongs will need unsoldering. And be careful, some of these tabs on here don't have a trace coming away from them, and if you overheat them, the whole thing just tends to come off the board. So you know, be a little gentle, is what I'm saying. But then it's just a simple case of getting stuck in with your soldering iron, like so. I'm going over them a couple of times just purely because some of them don't always come off as super clean as you want. If they tend not to come off cleanly, add a bit of solder back in. Sounds counterintuitive, but if the solder sucker hasn't got anything to suck on, it's not going to do anything. There we go. Right, once we're down to there, should have done this a bit earlier, never mind. You need a very small jeweler's screwdriver or something like that. Flip it over, have a good look at it, make sure you got most of the solder off all the way around, yeah? And then it's just a case of getting underneath it and popping it, and it should just come out like that. You might find they go click, 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 and they sort of crack as you're breaking a tiny little bit of solder. It shouldn't take a massive amount of force, but what you may find is that there may be a slight bit of resistance there. Yeah. So all the holes are clear. I can see straight through. So what we'll do is we'll put a new switch back in there. Yeah. And we'll solder it back on, and then I'll just repeat the process off camera for the rest. Don't know why I'm picking the solder sucker out. Force of habit, I guess. Then all you do is you just add a little blob of solder back in. Like so. If you end up with a very messy board when you've done this, just use a toothbrush and a bit of isopropyl alcohol. That's fine on this board. I wouldn't necessarily be doing that with a nylon toothbrush on the main board, because these are all passive components that can't really be damaged by electrostatic. The main board is a slightly different beast, and you have to be a little bit more careful with that. Right, I'm going to continue on and do the rest of these switches off camera, and I'll come back and I'll do the slider with you, and we'll dissect it so you can see what's inside it. So we've put all our switches in where we want to put them, giving it all your clean up. Now we're going to take this out. So here's the new one. As you can see, there's 4 solder connections there, 2 solder connections there, and the 2 in the middle basically just support it, and the 4 at the ends are the ones which actually do the work. So what we'll do is we'll take this one apart, get this one out, then we'll come back. you can see that. It'll focus, but you can see most of the solder is out. So you're going to get 99% of it out, but there's always going to have a little bit of bind against the holes. So what you may find you have to do is just to give it a little bit of persuasion, but don't be too brutal. Yeah. Chances are it will come, but you're just going to have to give it a bit of a chance. So give it a bit of a wobble from side to side. Yeah. Which helps. And then you might have a couple of them that are just going to be a little bit tentative. Yeah. But just don't be too brutal. If it feels like it doesn't want to come freely. Yeah. Doesn't want to come freely. And don't force it, basically. I can see all the way through the hole, so I'm happy. New one, it's bidirectional. It doesn't matter, there is no up, there is no down. It's the same from top to bottom. I can flip it that way up, it's the same. I can flip it that way up, it's the same. All it's doing is changing the resistance from one end to the other. So if that's up, it's down, it's measuring across. This is a 10K slider. I'm guessing it's dual channel. We'll find out when we get this one apart, but I'm pretty sure it is. Quite where the slider connections are and where the things are, I can't tell at the moment, but we'll work that one out. Solder this one in. Just be careful when you put this in to make sure everything goes through the holes where it should do. And as you're pushing anything through the circuit board, make sure that you're not lifting a track on the other side. It's all very easy getting things out because you're pulling the track onto the board. And when you're pushing things through the board, you could potentially push the track off the board. So just be gentle about it and have a good look. Yeah. Okay. Make sure it's seated well down before you solder it down. We'll do that. Do a quick bit of solder, and then we'll dissect the other one and have a look. Yeah, they all look good. Some solder iron off, some gases down to death. Right, that's our switchboard done. Obviously just have a look around the board, make sure there's not any little sort of flecks of solder that have gone where they shouldn't do, or anything like that. If there are, they should just be strays, but more likely to have come out of this than they are anything else. Right, all looks good. Right, let's put that to one. Right. There's 4 little tabs here. I'm going to dissect it anyway, just for fun, and you'll see. Then you can see why they go wrong and how they go wrong. So, bend them little buggers up. So. 2 more on the ends. Right. So inside here you've basically got this little thing here, which has got a spring. It's got spring tension behind it, and then a spring on the 2 little contacts there. You can see them. Yeah. So they keep a constant pressure on this. And I don't know if that's visible in there. Hopefully if we move it around a little bit you'll be able to see. There's 2 carbon tracks which run up and down the board. and the resistance from there to there is going to be 10k. So as these wipers are going up and down it, basically if it's halfway up it, it's measuring 5k. If it's 20% up it, it's measuring 20k, and you know, vice versa. So what happens in here is people spray this with IPA and anything else to try and solve a problem, yeah, and those tracks just wear off because they're basically being slid up and down on by that. So eventually when those tracks become broken, or you know, you'll get intermittent volume control. It won't be linear, and if both tracks fail completely and this isn't making any contact and there's no continuity through this whatsoever, what you'll end up with is a situation where you'll have no output at all. You'll hear things through the sampler section when you're monitoring, and then you'll go to play back and you'll have nothing. First instinct, if you've got no output, is always straight to that and measure it and see what you get out of it. What I can do, if you want, is I can get another one out at some stage, make a request, and I can actually put a meter on it and show you how it works properly.